So reflections is the one thing we add, and then we add stretches as well, and then we've done all the transformations that go together. So a reflection is a mirror image about a line or an axis. So for example, if your graph is above the x-axis and it reflects in the x-axis, the whole thing will now be below the x-axis, right? If it's in the positive x values of the graph and it reflects on the y-axis, it'll be now in the negative x values. So it does this, it reflects this way, or it reflects this way. Up or down, or left or right. Those are the two reflections we can have. Now, if we're reflecting left or right, what's being negated, the x's or y's? The x's, right? If they're positive x's, they become negative, and if they're negative, they become positive, right? So if our x's are negative, we actually reflect about the y-axis, correct? If our y is negative, if they're positive, they become negative. If they're negative, they become positive. They reflect about the x-axis, actually. Okay? That's all we're looking at today. So here we have a reflection in the x-axis. So in order to reflect in the x-axis, if you're confused and you don't remember which reflection happens where, think, okay, I have a negative in front of my f of x. Oh, thanks, board, for joining in. So does that affect my x's or my y's? Is it with the x? No, so it affects my y's. So anything that's in the bracket with the x affects the x's in mapping. Okay? Anything that's outside of the bracket with the x affects the y's in mapping. So this affects the y's, in the bracket affects the x. Y's, x. So I always say, if it was like this affects the y's because it makes a y, and then this affects the x, right? Okay. So I know that if I have a negative in front, I know I'm negating the y values. Is that a true statement? So my mapping for this would just be xy becomes x negative y. Thank you, friend. This is my friend. This is great. I call you my friend, but she's like she's my adult friend. Like, you guys are like my friends, but then you leave me and go on and live your life somewhere else. Mrs. Wade stays. Okay. So we have x, y, and then x negative y. We agree? Now, people will forget, is it reflection in the x, reflection in the y? So they go into memorization. Memorization scares me. I've said this numerous times. I will say it every single day probably until you leave me. You'll be sick of it. But memorization scares me because if you have something memorized kind of wrong, or you're like, I think it's this. I think it's this is the craziest, creepiest statement in all of math. I think it's this causes you to pick an error that's common that is going to be on the test, right? I think is not a good thing. I know it's this. So I think about it. My y's are being negated, correct? So I use my hand and I think about it. My graph, I visualize the graph is in the top right quadrant, so quadrant 1, okay? If I negate my y's, what happens? They're all positive currently. Where do they go? Negative. If they're all negative, where do they go? Positive, negative, positive, negative. What axis am I reflecting on? X. So it should make sense. It shouldn't be memorized, right? If my y's are positive and become negative, my y's are negative become positive, it's reflecting in the x-axis. My hand can do it. You should be doing this at a test, honestly. It'll help you. Also airs you out, you know? Good. So, all right. So, our y's are negative. We have a reflection in the x-axis. So here it says the graph of f of x equals x squared minus 4x plus 4 is shown. We're going to actually draw it. So you're going to type it into your calculator. And then you go second graph, because you get a table of values, right? First off, you can press graph so you can see where it actually exists. Then you can go second graph, and it gives you the table of values. Everyone should have gone to the table of values before this in your life. I hope this is not your first moment of table of values. Mother Terror is lending me to believe it's the first time. That's fine. We're going to go second graph. If it is your first time going to the table of values, it's like I'm an angel who's come down from heaven, and taught you where points are, and your life has gotten better. So that's good too. Second graph gets you points, correct? So we can just plot them. So I have -1, 9. Now I don't have enough ticks for 9. So I could either make my y scale be 2. Why are we all looking at me like I'm crazy? I have it typed in. Okay, so we could make our y scale 2, which I'm going to prove that to you. So we can go y scale.
Wait, which one are we typing in?
What are we doing?
I got the x squared, like.
Yeah, it's -1, 9.
What?
This?
That's 0 before. Yeah.
Yeah, guys, arrow up. Arrow up.
Ah.
Use your arrow and arrow up.
Yeah,
All right. We're not getting ahead of ourselves because I lost you at typing it into the y equals. So we're going to. We have it in the y equals? Yes?
Yes.
Okay. Then we can press graph. There's even this cool thing which I'm sure you know, but I'm not sure you know. Zoom. I feel like you guys just like all your math knowledge fell out of your heads already. Zoom and then 6 sets your window back to standard. Now you calculate that. That's okay. You can play along with others. So zoom 6 gets you your standard window, right? It just makes it -10, 10, -10, 10, just in case you don't have that. Now you can kind of see where the graph is, correct? Doesn't it look like it's possibly like the vertex looks like it's possibly at 2 or something? Can we find the vertex? Yes. Is this a maximum or a minimum graph? Minimum, because every valley is a minimum, right? The very minimum you could go and you have to climb back up the valley. We agree? So how we found a minimum last year is we went, everyone's following along, second, trace, because that's where you're going to calculate everything for the rest of the year. Minimum. Then it says what? Left bound. So now you need to be on the left side of the minimum. So if this is your graph, here's your minimum, you need to be somewhere over here and hit enter. And it says right bound. So you need to be somewhere over here and hit enter. Then it says guess, and you just hit enter. I don't know, you have to let it guess. What does it give you? Okay, so it gives you 2 and 0. Some of you will get like, instead of a 0, you'll get some crazy decimal with an e to the negative something. What does e to the negative something just mean? It just means 0. It just means 0 decimal, and it's like e to the -9. It's 0 decimal 0, 0, 0, 0, 0, 0, 0. I've lost count. But 9 zeros and some numbers, which we can round to 0, correct? So you always have to look and see if it says e to the negative something behind it, because if it does, it is 0. Okay? Don't write me like e to the negative something. Don't write 1.6. So we know that this thing is starting at 2, 0. So once I know that, that's where I figure out my starting point for my table. Now, I'm showing you something here. I made my y scale be 2 and my x scale be 1. The catch when you change your scale is that you have to remember you changed it. Okay? So if I go to my table of values, I'm going to go second table, or second graph, and I'm going to go to 2, 0. Correct? And I'm going to set that in the middle of my screen because that's the middle of this graph. That was my minimum. Yeah? Now above it is 1, 1. Now I have to watch myself. 1, 1 is not the first tick. 1, 1 is here because I made each tick worth 2 so I can put more points on it. Correct? Then it's 0, 4. 0, 4 is here. Then it's -1, 9. 2, 4, 6, 8, 9. Then it's 16. It's too far off. So then I work my way back the other way. 2, 0, 3, 1. 4, 4. 5, 9. And I connect them rounded. And when I get here, I don't just go viciously making an arrow wherever the heck I feel it needs. Once I got to the end of that point, that's all that's accurate now, right? So I can go a little above it, and then I put an arrow and saying that it keeps going. And I do the same thing over here. I go a little above it, and I put a 0. After this, you guys will like just hum a line up as far as you think. You can't. There's no point to connect it to. You can't just like draw them for life, okay? So you need points for accuracy. So that's our original. That's this one. Now we want the equation of negative f of x. Well, what is f of x? F of x is this equation, is it not? So I want y equals negative, and then I fill in f of x. I fill this in, because that's what f of x is. But I have to put it in brackets. So I actually get negative x squared plus 4x minus 4, and I'm going to put that into my y2. Now clear out my y1. In my y2, I'm going to put that. Now the reason why I'm not doing this on the board on my calculator, which normally I would do, is because the moment I bring up my calculator, you put yours down. And you guys didn't know how to run any of it. So I now cannot trust that if I send it, that you will know what we're doing. So I'm making you do it on your own. Okay? So we're going negative x squared plus 4x minus 4 graph. Now I know you guys were taught all of this, but I do believe that it has temporarily left the building, but I believe it will come back very quickly because it's just temporarily left the building. Where did this reflect on? Or reflect in? The x-axis, correct? Now remember, we don't actually need to use the table of values to draw this. Remember, our mapping is this when it's a reflection in the y. Or reflection in the x, sorry, a negative with the y. It's going to be xy becomes x comma negative y. We agree? So all of our x's are staying the same and our y's are negating, are they not? So I know that I had negative 1 and 9. Well, that's going to become negative 1 and negative 9 when I plug it into mapping. Two, 4, 6, 8, 9. Remember, it's 2 each. And then I had 2, 4. That's a lot. 0, 4. Which is going to become 0, negative 4. Now this 2, 0 is going to become 2, negative 0. Is there such a thing as negative 0? No. So these stayed the same. Do you see that? When I applied my transformation, it stayed the same. Before I go and draw more, I'm going to go, that's an invariant point. An invariant point is a coordinate that stays the same. Sometimes there's more than one. That stays the same. After you performed your transformation. So the invariant point on this one is 2, 0. And it stayed the same because that's where the reflection is. The reflection is the x-axis, correct? Now, I say this to people and no one ever has ever done this, but I did it as a kid and I just assumed everyone else did it. But have you ever taken your toothbrush and like pushed it against the mirror? Well, you're missing out. So when you put your toothbrush against the mirror, your toothbrush will reflect in the mirror, correct? The only thing that doesn't reflect is what's against the mirror, correct? Because that's the reflection spot. So that's why when we reflect here in the x-axis, our x-axis is the mirror, and the rest of the graph will reflect, but right here is going to remain the same because it's what's touching the mirror. Try it out. Yeah.
So is there only one invariant point?
On this one there is, yeah. So if there was x-intercepts, if there was two x-intercepts, let's say the graph went below instead, then there were actually two invariant points because those will stay, and the little, say it was concave up and this part was below, that'll be above now, and it'll be concave down now, but your x-intercepts aren't going to change because that's where y equals 0. So wherever y equals 0, you're going to negate a 0. So it's going to stay the same. Okay, and then we have this one becomes, nope. One goes here, this one goes here, this one goes to 9. So how does the graph of negative f of x compare with the graph of y equals f of x? called a reflection in the x-axis. So remember, this is just transformed form. Why is it transformed form? Because it's an equation with an f in it. We agree? Then we have our two other things that we, remember there was three things that we can show meaning the exact same thing. We can have transformed form, we can have words, or we can have mapping. In this case, xy becomes x comma negative y. If it's not in the bracket with the x, it affects the y in mapping every single time. Okay? So everything on the outside makes that y, it affects the y, anything in the bracket affects the x. So here's a graph shown. I want you to draw this. What does this mean? When there's a negative in front. Yeah, it affects the y, so it's going to be xy becomes x negative y. What is it in words? And we're moving coordinates, correct? We're moving like this coordinate, this coordinate, this coordinate. We can move this coordinate if we want to. The moment we move coordinates, what do we use? Mapping. Let's try it out. How many invariant points does this graph have? 2. It's where it's on its reflection. So it's reflecting on the x-axis, reflecting in the x-axis, so those are going to remain invariant. This one is at 0, 2. It's now going to be at 0, negative 2. My vertex is at 1, 2, 3, 4, negative 1 and 4. So now it's going to be at negative 1 and negative 4. Now it should look like it's reflecting in the x-axis, right? What's below becomes above, and what's above becomes below. Then we're flipping over. So on the next page, where's the x, sorry, I just gave you the answer. Where is the negative with? The x this time. So in mapping, where's the negative going to be with? X. So we know that this means our mapping is xy becomes negative x comma y. Now if I think about it, if I have x's that are positive here, and I negate them, they're going to be here. And if they're negative, they're going to be here. If they're positive, they're going to be here. So the positives move to, say, quadrant 1 moves to quadrant 2, quadrant 2 moves to quadrant 1, quadrant 1 moves to quadrant 2, quadrant 2 moves to quadrant 1, right? So what axis am I reflecting in? The y this time, right? So it's a reflection in the y-axis. Once again, we're moving back to grade 10. So I'm going to sketch the graph again how it was. So I'm going to make my y scale 2. I have to write what my scales are every single time. X scale 1. So I had negative 1, 9, 4, 8, 9. I had 0, 4. I had 2, 0, 2, 4. Oh, 3, 1. Oopsies. 1, 1. 2, 0, 3, 1, 4, 2. No, 4, 4. 5, 9. So if my mapping is xy becomes negative xy, all my y's stay the same and my x's are being negated. So now where's my invariant point going to be? Which axis? The y. And the reason why that is if I have 0, 4, I'm now going to get negative 0, 4, which is actually just 0, 4, right? It stays the same. And then if I go negative 1, 9, it's going to become positive 1, 9. And then I have 1, 1. It's going to become negative 1, 1. Two, 0 becomes negative 2, 0. Three, 1 becomes negative 3, 1. 4, 4 becomes negative 4, 4. And then 5. Does the blue look like it's reflected in the Y? Yeah. Now the last one, we had a negative in front of our f of x. We agree? Here's where we're going back to grade 10. If I gave you, don't write this, I'm just proving something. If I gave you f of 2 in grade 10, what does that tell you to do? Anyone remember? The equation is f of x, is it not? So what would you do? So it's f of x, it's f of 2. So you're going to put 2 in for all the x's, correct? Make sense? So if I did f of a, you would put a in for all the x's. We agree? If I did f of smiley face, you would put a smiley face in for all the x's, would you not? This one doesn't say any of those. This one says y equals f of negative x. So what are you going to actually do? Not put smiley face in for the x's, not put a in for the x's. You're going to put negative x in for all your x's. So the original equation is y equals x squared minus 4x plus 4. Or we could say f of x equals x squared minus 4x plus 4. Now in for every x, instead of having an x here and an x here, I'm going to rip those x's off the board. I'm going to throw them to the side, and I'm going to replace them with negative x. So I'm literally just replacing, it's function notation. It's telling you what to replace the x's with, right? Now what happens if I get negative x and I square it? What is negative x? Anything negative squared result in? A positive. So we get x squared minus 4 times negative x is plus 4x plus 4. So now type that into your y2 and see if you get the reflection. You can always check your equations. If you're trying to find a reflected equation, you type your original in, type in the one you found, and they should reflect, right? If they don't, you oopsie. So you clear out your y2 and now put that in. X squared plus 4x plus 4. Bless you. I want to show you something as well on your calculators. If you have the colored calculators, you don't need to pay attention to me, like the ones that have colored graphs. If you do not, you have to pay attention to me. So they draw the graphs onto your calculator in order of equation, correct? So y1 will always be drawn first, y2 will always be drawn second, y3 would be drawn third, etc. Right? Everyone paying attention? So once they're drawn, though, they're both just sitting there, are they not? Do you know which one's y1, y2? You go work on something else, you come back and you're like, ruh-roh, I don't know which one is. So what I always do if there's two graphs, everyone's doing this, go to your y equals, and you're going to go down to your y2 equation. Everyone paying attention? Go to your y2 equation and arrow to the left past y2 until you're on the slanted line and it's blinking. Is everyone on the y2 slanted line blinking? Everyone there? Hit enter once. Now press graph. Y1 will be the thin line and y2 will be the thick line. Then you'll actually be able to tell the difference. So you go to your y2, you arrow to the left until you're on the slanted line that's blinking, and you hit enter once. Now please don't spend the next few years hitting enter and seeing what else is there. There's dots, there's key looking things, they're useless, there's some shading, I don't really care about it. The only one you want is the second one, which is a thicker line. And then your y1 will always be the thinner line, your y2 will always be the thicker line, and you'll know that's the difference between the two. Okay? How does the graph of y equals negative f of x compare to y equals x? F of x, it's a reflection in the y-axis. And your xy becomes negative xy. And then I want you to do this one. Your homework for tonight is to finish that review, the rest of that review that I gave you. The rest of the Perm and Com review. So if you got to number 12, you're halfway done. That's the only homework you have. I'm not making work on transformation homework. Okay? So we're finishing up reflections and stretches tomorrow. Put them all together Thursday. So finish your review for tonight.